One of the greatest challenges of traditional RDBMS was scaling. Traditional RDBMS were not designed to be distributed. However, there are two methods that we invented in order to scale a traditional RDBMS, and these were either vertically or horizontally. Vertically or upscaling involves the upgradation of hardware. You can get faster CPUs, more memory, or larger disk size, and technically make your server change it into a bigger machine. But this is severely limited by the amount of CPU, RAM, and disk that can be configured into a single machine. One cannot add an infinite amount of RAM or memory into one machine. The other method is horizontally. This is also known as outscaling. In horizontally, what we can do is add more machines. And by adding more machines, we achieve distribution. But this requires either sharding or maybe replication of data. And this is again limited by the read-to-write ratio and the communication overhead between multiple machines. So let's discuss the horizontal scaling a little more. In horizontal scaling, we can have two methods, either this master-slave method or the partitioning method. In master-slave method, all the writes are written to the master. There is one central machine that is known as the master machine, and everything is written to just that machine, while the reads are performed against the replicated slave databases. So you've got one central point, and all the clients talk to only this one. And the data present on this one is distributed to all of the slave machines. Every time when there is a write request, only this master can be accessed. But if there is a read request, then the client can directly communicate with the slaves. So for reading, we can involve the slaves, and for writing, we involve the master. This reduces our overhead of read-write. Critical reads, however, may be incorrect as writes may not have been propagated down. This causes a problem or error if there is a delay between the write that has been done on the master to be propagated to the slaves and a read request was made in the same time, then these reads may be incorrect. So there is a problem with the speed by which we transfer the writes from the master to the slaves. And large datasets can cause problems as the master needs to be duplicated to slaves. So if there is a large dataset, you'll be constantly having, or you'll be having a lot of traffic on this area where the master keeps on propagating its data to the slaves or effectively keeping them in sync with one another. The other method is using partitioning, or also known as sharding. In partitioning or sharding, we split the databases onto multiple machines, and this is why it scales well for both reads and writes. However, it is not transparent. If you need to access some part of your database, you know which physical machine that it lies on. So the application is aware of there being more than one servers, and it is also aware of what server contains what data. Then there is the trouble of having joins across partitions. If some of your data resides on server 1, some data on server 2, and some data on server 3, then it's difficult to have joins or perform joins across such partitions. And there can be a problem of loss of referential integrity. So if there was a table over here that had the primary key that was being used as a foreign key in the table of the table that resides on server 2, then this would not be easily maintainable. There may be a case that the primary key has changed because it resides on a different server and the foreign key has not been correctly updated. So we may have a loss of referential integrity across shards. Based on this partitioning or sharding, we can split data in by multiple methods. The first method is vertical partitioning. So you can have tables related to a specific feature sit on one server, and then the tables related to some specific or other feature present on the other server. So we split the tables, have some tables at one part and some tables on another part. There is also range-based partitioning. If you can not correctly split tables, there are tables that you need all of the time. So one server cannot have only one subset and the other cannot have the other subset. Then you split the table based on data. In terms of splitting based on data, you can have values or critical value division. So half the data below some range is present on one server and the other half above some range is present on the other server. We can also have key or hash-based partitioning. In key or hash-based partitioning, we divide every row or we perform a hashing function on each of the rows, and then whatever the key generated, that key is corresponding to the server number. So based on the key, we place it into its own or its corresponding server. Lastly, we can have directory-based partitioning. So we can have a lookup service that has knowledge of the partitioning scheme, which tables reside where, which data resides where. And this is considered a good approach when we need to add more servers. If at any time we'll be requiring more servers, then it is better to apply the directory-based partitioning. Some other methods to scale RDBMS involve multi-master replication. Multi-master replication system is responsible for propagating data modifications made by each member to the rest of the group and resolves any conflicts that might arise between concurrent changes made by different members. So instead of one master, now we've got multiple of these, and they essentially perform the same tasks. Then you have the insert only and not update delete scheme. For insert only, data is versioned upon update. When you create an update statement, a new version of data is created instead of the actual update. So it's again essentially an update is converted into a new insert statement. Data is never deleted. You can only deactivate it or activate it. Since joins are expensive, so we can have a scheme where there are no joins at all, and thereby reducing the query time. With larger volumes, joins may or may not work across partitions, and again, they are expensive. So we do a denormalization. We can either do a denormalization